I appreciate you guys coming this morning. My name is Joe Tentacoste. I work for Mytech Corporation, which is a parent company that owns Atlas Sound, which is what we're going to be talking about today. I'm going to tell you a little bit about Atlas, give you a little bit of history about what we are and where we come from. I'm going to go into a lot of 70 volts, kind of defining what a 70 volt system is, why you should use it, some of the job applications for it, and then I'm going to show you some product stuff. Probably take 2.5 to 3 hours, I hope. If we get done sooner, we'll get done sooner. If you have any questions, there's probably a lot of questions about 70 volt that I may not be able to, that I'm not answering in the presentation. If you have them, I'd love to answer them if I can. All right, so Atlas IED. Atlas Sound, you guys probably see that on the cartons if you've ever done it. You may have heard of that brand before, and now I'm showing you Atlas IED. I'll give you a little history on how those two things came to be one. What is 70 volt, why you should use it, commercial and residential applications for both, and then we'll do some talking about how to find jobs. That's one of the biggest questions that residential integrators always have, is how do I get into the commercial business, how do I find those opportunities? So I'll share some of that, what I know. Maybe you guys are doing something that I'm not going to talk about that we can share with the group. We'll go from there, and then we'll get into some product stuff as we get into it. So Atlas Sound. Atlas Sound's been around since 1934. The company that I work for has not owned them that entire time. Atlas Sound started off in Parsippany, New Jersey. They were really a paging speaker company, and they made mic stands. It's kind of a weird combination. I have no idea why they started in those two categories, but they've been doing it for a very, very long time. Still two products that we make today. Some of the products that we make today were made in 1934, believe it or not. We haven't changed the models because why change it? And if it ain't broke, don't fix it. So we're still selling stuff that we sold that long ago, but we're a lot more than that now. So the Atlas Sound headquarters is in Ennis, Texas. It's about 45 minutes south of Dallas. It's about 600,000 square feet. It is a manufacturing facility. We do a lot of stuff there. We do a lot of final assembly on a number of products, IP speakers, sirens, horns, that kind of thing. We also build all of our metal products there. So our back cans, racks, rack accessories, baffles for speakers, all of that is done in that building, paint lines, all kinds of different stuff. We also do all of our shipping out of there. So if you're in the St. Louis area, which I assume all of you guys are within an hour of here, to get our product to Skywalker here, it's 2-day shipping, so you guys can have it within 3 days. Of us shipping it out. So it's a relatively quick turnaround time. So if you're quoting a job, you're going to get it pretty soon. We'll talk about that a little bit later. So paging and mic stands is where we started. We're a lot more than that now. I've got a selection of products here, but we're amplifiers, we're sound masking, which is something we're going to spend a lot of time on today because it's a big opportunity for you. We're IP speakers. There's just a lot of different stuff that Atlas has gotten its hands into. You can do almost an entire commercial job with just Atlas. The only thing that we don't make is microphones if you need paging, and wire, which you can get from Skywalker, of course. So you can get almost everything else you need for a job under one roof, which is one of the advantages that we have versus other manufacturers that are out there. So just to give you a little background, Atlas Sound, we do a lot of stuff for a lot of people, a lot of Fortune 500 companies, whether it's sound masking systems in corporate headquarters, whether it's sound reinforcement in conference rooms, whether it's paging at airports, train stations, all that kind of stuff. I just spent, unfortunately, 9 days at the Circus, yes, in Las Vegas. If you've ever been, I highly recommend it. But we were out there for the SEMA show on our car audio side, and as I was walking through the Circus, unfortunately, in the last 10 years that I've worked for Mytech, every time I go into a building, I look up and look at speakers, and it's packed with Atlas Sound speakers. So casinos, there's a Rubio's Baja Grill by my house. It's got Atlas speakers in it. I look for it everywhere. I see a nice Atlas speaker on the wall over there. Nice job, Skywalker. So that's good. I didn't put your logo up here yet, but it's because you guys aren't big in the category. So a lot of companies choose Atlas. When you think about commercial audio, probably Harman is one of the big names that's out there with JBL and Crown amplifiers. Bose is obviously a big one in the speaker world. But when you talk to commercial integrators, Atlas would probably be the next brand that goes into that conversation of the top 3 that are out there as far as parts and reliability and all that kind of stuff. All right, so like I just talked about, we're in a lot of different kinds of places. Some of these may be too big for you guys. I wouldn't recommend that as a residential integrator getting into commercial audio that you bid on an airport. It's going to be a very complex job that you probably don't want to mess around with. However, there's a lot of low-hanging fruit out there for guys in our industry. Arizona We love building strip malls. They're lining the highways, they're lining every street, and there's 10 or 12 different businesses in there, whether it's a nail salon or a restaurant or a retail store. Everybody wants music now. And so you can either run an 8 ohm system, which can be a little bit expensive, or you can do 70 volt, which is super easy, and you can make a lot more money on, and we'll talk about that a little bit later. So Innovative Electronic Designs, this is the IED part of Atlas IED. Innovative Electronic Designs is located in Louisville, Kentucky, and they've been around for about 40 years. They make paging stations and paging technology for airports and transportation hubs. They don't do any speakers. It's all amplifiers and interface devices. When you go to the St. Louis airport and you see the lady pick up the microphone, we're now boarding zone 1 or zone 2, whatever that is, that's an IED handset running through an IED paging system. A lot of technology is into their products. They have a lot of ambient noise analysis capability, so as the room gets louder, the speakers will automatically adjust themselves to be louder. As it gets quieter, it'll adjust itself back down, built-in DSP, built-in, they send a signal out every 20 seconds to make sure the speakers are working. So in 2008, the gentleman that owns MyTech saw an opportunity to purchase Innovative Electronic Designs and bring the two together because they're in 80% of the airports around the world. That's a great opportunity to sell more Atlas stuff, whereas before they were just doing the paging system, letting the architect specify the speaker. They're now doing the whole paging speaker system as well as recommending the Atlas product to fill out the rest of the system. So just this year at the InfoComm show in June, we combined our sales and marketing teams. We're now branding it as Atlas IED, which you'll start seeing on cartons and stuff like that for stuff going forward. Doesn't change any of the history, doesn't change any of the technology. It's just the two companies sharing me as a resource now. So 70 volt systems. Does anybody have a question about 70 volt right off the bat that I can answer, that I may answer in a minute, but we might as well ask it up front? Anybody got any, what's the one thing you wanted to learn today about 70 volt systems? You guys all came here for a reason. What's the one thing you hope to learn today? Come on, someone's got to be first. I'll call on someone. I totally will. All right, you moved closer, which I like, so you're unfortunately got to be the guinea pig here. What's the one thing you hope to learn today that I can teach you?
The 70 volt thing has been kind of a mystery.
Okay.
Nothing like the 8 ohm stereo, regular home unit.
Okay.
And we use quite a bit of commercial stuff, and I just don't want to short anything out. I get the principle.
Okay.
You use smaller conductor and you've got a carrier, but I don't know the ins and outs.
Okay, good. We're going to talk a lot about that. Anybody else? All right, well, let's jump right in. So 70 volt, constant voltage. A lot of people get scared when they hear the term 70 volt because it sounds like electricity. And we're all speaker guys. We know that an 8 ohm speaker goes to our amplifier and it works and everybody's happy and it plays. So when you hear about constant voltage and 70 volt systems, this has been around for about 100 years. And really, it's because of large installations. So in a big building like this, if we had paging speakers in the warehouse and we had speakers, if this wasn't a concrete floor and we had speakers mounted in here on all 3 levels, that's a lot of speakers and that's a lot of speaker wire. So say in a building like this, if we were going to run that as an 8 ohm system, we'd probably need a couple of 12 or 16 channel amplifiers. We would need a lot of speaker wire to run one out to every speaker that's in the warehouse and come back, right? So in the early 20th century, guys didn't want to do that. It was too much wire and it was too much time. So they decided to use a 70 volt system. Now, 100 volts is actually, 100 volts is where 70 volts started from, okay? But 100 volts, you got to have conduit. So when you think about power equals voltage times current, to get 100 watts, you can do a 10 amp times 10 volts and you can get 100 watts, our Ohms wheel, which we'll talk about later. Or you can do 100 volts times 1 amp and still get that same 100 watts. So we're talking about a much smaller cable in order to carry that electricity, so it's a lot cheaper. If you're going to try and carry 100 volt or 10 volts across 10 amps, you probably need a 12, 10, 8 gauge wire, depending on how long that run's going to be, and that's going to be really expensive. Our car audio side, we sell 10 gauge bulk wire and it's $365 for 250 feet. Your customers may not be real happy about that when you can buy a box of 16 or 18 too for half that price. So this is just a means to get that same power out to the speakers using much smaller wire because it's a lot cheaper. So So you've probably seen 25 volt, 70 volt, 100 volt, and it's kind of confusing. What's what am I doing? Why do I want to do this? 25 volts, very low voltage. Most of our speakers you can tap at either 70 volts or 25. Doesn't matter, and most of our amplifiers will also play in a 25 volt system. Just depends on what you're doing. The majority of the systems that are getting installed in the United States today are all being run at 70 volts. Can't really give you a good reason for that, other than that's become the accepted norm. 100 volt in a lot of jurisdictions, which we'll also talk about later because that's very important. A lot of those 100 volt systems, you've got to put conduit around the speaker wire because it is a higher voltage, so if something did happen to the wire, they want to make sure it's contained. They don't want to have a fire on their hands or something like that. So 70 volt is sort of the standard now, and that's what we're really going to be focusing on, although a lot of our products will do these other voltages. When you're talking about commercial audio in the United States, 70 volt really is the way that you're going to go. 100 volts used a lot in Europe. Europe has a lot of regulation, even more than the United States, surprisingly. They have a lot of regulation and require 100 volts with conduit. You know, whether that's to make more money or that be a hassle for companies to do business, I don't know the answer to that. But what's that? But so 100 volt is the standard in Europe. So what is a 70 volt system? It's an amplifier, it's speakers, it's speaker wire, it's a couple of sources, and it's going to deliver background music, paging, maybe some, what else could it do? You know, you're going to do messaging, you're going to do, I mean, it can do a lot of things depending on what you're connecting to it. So it's just like a home audio system, just with different products connected a different way. All right, so just like we talked about, you got to have the same parts that go into your residential audio system go into a 70 volt system. It's pretty basic. Connections are going to be a little bit different, which we'll talk about in a minute, but all the same stuff that you would put into a house, you would put into a 70 volt system. So what are the benefits? Lower current draw. Can use much smaller wire over a much greater distance. It's cost efficient. 70 volts generally cheaper than doing 8 ohms, both in wire and in the speaker itself. And it's easy to design. If you're going to do a distributed audio system in a home, for instance, you know, you're going to do 5.1 in the living, you know, the family room where the TV is, and then you're going to go zone 2 out to another amp and try and distribute it out. You've got to worry about matching impedance. You've got to put in a speaker selector. You know, you may have to do some control products. I mean, it can get pretty sophisticated to do. 70 volts much easier to design. You know, as soon as you figure out the number of speakers that you need or where they're going to go, it's a matter of making sure that the total wattage that you're going to tap the transformer at doesn't exceed 80% of the power of the amplifier, which we'll go into in pretty good detail.
Well, that was one of the questions I had is, if you have, let's say, 3 speakers running in an area, tag one on, can you put that in the middle of that run?
As long as the total wattage that you have them tapped at does not exceed 80% of the amplifier's power rating.
But it doesn't matter that they're not in 8 ohms?
Nope, because it's going to be a transformer. So this is a good question. So let's imagine that you wanted to add 3 speakers to a kitchen. And you want, you know, stereo is not important at that point in time, right? If you're standing in your kitchen, left and right is not going to be a big deal to you. You just want background music in the kitchen. So let's say we're going to add 2, so we come zone 2 out of our audio video receiver into a 70 volt amplifier. We then put 1 speaker wire on that amp, run it to the 2 speakers. Let's say we tap them both at 8 watts, which is going to be, which I'll prove to you is going to be as loud as you would ever need for that system. So that's a total of 16 watts. So if we had a 30 watt amplifier in there, no problem, it's going to work great. If you wanted to add a 3rd speaker in, another one at 8 watts, you can do that as well, because now you're at 24 watts, you're still less than 80% of the power of that amplifier. If you wanted to add more speakers onto that line, you just have to tap them down, which would be okay, because now you're adding speakers to the room, and every time you double the amount of speakers you have, you gain 3 dB inverse square law, which we'll talk about a little bit.
My question is, do we have to try to maintain 8 ohms impedance?
No, you never have to worry about 8 ohms. You got to worry about wattage. When you're talking about 70 volts, you got to worry about wattage, not impedance. And 8 ohms is not going to be, I don't even want you to think about 8 ohms when you're doing 70 volt. Let's just throw that right out the window. We're not even going to do it. Mr. Ohm. So it's easy calculation, like we were just talking about with the system wattage. Keep it under 80% of the amplifier's power. If you've got to add more speakers eventually, you may have to upgrade the amp, but that's all you've got to do. You don't have to run more wire. You don't have to, you know, change wire. Everything can stay in line. You could actually do individual volume controls. which we'll talk about in a home audio application. So that way, you could be off in a room, and if you wanted to listen to it, you can turn the volume up, and it would work great. And then the transformer, which makes it a 70-volt system, is going to step down that voltage and give you the power that you need. Every speaker up here that I have is 8 ohms. It's the transformer attached to it that makes it a 70-volt speaker. Okay, so the speaker, nothing really changes on the speaker side. This speaker that I've got sitting up here, all of these, just like the speakers you're doing now, just with the addition of a transformer, so that I can see a 70-volt system, so that it's easy to wire and it's easy to use. Cool? All right, so this is important. This is probably the most important thing that we're going to talk about today, are these considerations. Okay, when you talk about a 70-volt job, you've got design build, and then you've got a bidding project, okay? So design build is where you are actually, someone comes to you and says, I need to do this audio system in my building, can you design it? So you are essentially the architect, you are the system designer, and you're also going to be the installer. You're doing the whole thing. Much the same as you're doing now in your home audio projects, just on the commercial side. You have total control over this. Everything that goes into it is going to be up to you. So unfortunately, if something goes wrong, you're on the hook for it, all right? In a bid project, someone is going to say, I have this building. A lot of municipalities do this. Some corporations do this. You'll see a lot of chain stores, chain restaurants, franchises, because they have to go by their corporate rules. It's got to go out to bid. It's a good opportunity for you guys to bid on projects, because a lot of times bigger guys don't want to mess around with it. But in a bid project, you've got to do what the architect wants. So the architect has specified, I need an amp, and I need 8 speakers, and I need them to be here, here, and here, and it needs to have this capability. So at that point, you have to try and find product that's available to you that matches that specification. So you're following their rules. Now the advantage to doing this, there's advantages to both. Design build, it's up to you. You're doing all the work, right? So you can charge for the work, which is good, because your labor's going into it, your time, just like an architect would or an acoustical engineer would. So you can bill the customer for that, because you are doing that work. Now you have to make sure that the system that you're going to build is in compliance with the jurisdiction that it's in. You'll hear the term AHJ, the authority having jurisdiction. Very important, because depending on where you live and in what city it is and what county it is and what state it is, there could be a whole slew of rules that you have to make sure you follow, because if you go into a commercial job and you do it, and then the building inspector comes in to sign off on the building and he says, this isn't right, this isn't right, this isn't right, well, now you're back in there trying to fix those problems, because the customer can't open their building until it's ready, and now you're on the hook for doing that, probably at your cost. So doing the research up front is going to be super important to make sure that you're going to meet all of those jurisdictional requirements. So back to design build before I get into that. Atlas Sound offers free design assistance. Free design assistance. If you go to our homepage, atlasIED.com, and you click on support, you go to a page like this, and you can say, I have a job I want to do. It's a paging job, it's a sound masking job, it's whatever. And then there's a series of questions. What are you trying to accomplish? What are the details? Do you have a PDF of the blueprint that you can send us? Now, don't send this to us the day before you need the bid, because it's not going to happen. Okay? You got to, 2 weeks is usually their turnaround time. Well, we say 2 weeks. They usually get done faster than that. But we have guys on staff that this is all they do all day, is bring in jobs, lay it out, send it back to you with the exact parts you need, where you need to put them, what you need to tap them at, the whole works. So all you got to do is submit that and say, this is what we're going to do, and then your installer takes that out there, puts everything where it needs to go, sets it up the way they said to set it up, and you got no problems. Okay, this is a free service that is available to you guys that I highly recommend taking advantage of as you're getting into this 70-volt world, because our guys have probably 60 years of experience doing this, and they're very good at it. So free service available to you guys. I recommend doing it. Safety listings. We were just talking about compliance, and the next couple of slides are going to be about compliance. Has everybody heard of UL? UL listed. Okay, so UL listed has become the Kleenex of the audio compliance world. UL listed is just an adherence to a certain set of standards that were created by ANSI. So ETL also has the ability as a nationally recognized testing laboratory. That's what NRTL means. They have it's the same thing. It's talking about the same requirement. So it's just a different agency that certified it to that standard. UL's got 1,304 standards covering a wide range of things, like an unbelievably wide range of things, where you can put, you know, stuff on the floor, where your emergency exit sign has to be, where all this other stuff goes into. So if you're an architect or a builder, you got a lot of stuff that you got to think about. Luckily in the audio world, these are the ones that we got to worry about as a general rule. So UL 1449 covers surge protective devices. You know, your local authority may require that you're using a product that meets this specification. Okay? If you bring one in there that doesn't, you are going to be pulling that out and bringing another one back. Okay? And chances are it's going to be more expensive, so if you underquoted the bid, you're going to wind up eating that difference. Okay? Because UL certification is not cheap. A lot of stuff from overseas coming in doesn't have UL certification on it, so you can't use it in a job that requires it. 1480, this one's huge for in-ceiling speakers. Almost every speaker that Atlas makes, almost every speaker Atlas makes, is UL 1480 listed. This is for use for paging systems. Part of the NFPA 72 code. If you ever really want to go to sleep and you're having a hard time, download it. It's like 300 pages of the most boring technical stuff that you've ever heard in your life. But it's important because you got to understand it, because it all goes toward this. Okay? When we talk about UL listings and the NFPA 72 fire protection code, this is all part of that. UL 2043, if you're going to put a speaker above the ceiling, you're going to put it in the plenum space. It's got to be rated for that, because if it shorts or it catches on fire and that plastic is not certified to not burn immediately, you know, some speakers will light on fire and burn, and then burn a building down. So if you're doing a job and you put a speaker in that doesn't meet that specification, and the building inspector doesn't catch it, and that building burns down eventually, hope you have good insurance, because the business owner is going to come after you when the fire marshal gets done and says, this is the speaker that caused it. All right. UL 1678, racks, cabinets, and stands. I'll talk about that in a minute. That whole thing's not a rack. One part of it's just a display. But again, it's got to meet a certain standard for safety. It's not going to tip over. It's not going to bend. It's not going to twerk. There's a lot of different things that go into that. And then 6065. This one really covers electronics. You know, does it have a UL listed power supply? Does it have fuse protection? Some of these other things that go into electronics to make sure that if it does have a problem in a rack, that it's not going to burn the rack down and light the place on fire. So again, knowing exactly what your jurisdictional requirements are and making sure that you're meeting them is super important. So I downloaded this off the City of O'Fallon website before I came out here, and I'll read this verbatim to you. A certain document, a copy of which is on file in the office of the City Clerk of the City of O'Fallon, Missouri, being marked and designated as the National Electric Code. 2008 edition is published by the National Fire Protection Agency B and is hereby adopted as the electrical code of the City of O'Fallon in the state of Missouri. So this is actually pretty easy. If you're in O'Fallon, chances are it's pretty similar in all the cities around here, no matter where you're from. Because I'll show you another slide in a second, and Missouri's pretty lenient on their licensing and regulation requirements. But so the NFPA 72 is the electrical code, and there are part of that is specifically pertains to audio systems. What kind of wire are you using? Is it class 1, class 2, class 3? Is it being run through conduit, depending on what it is? What kind of are you doing 70 volt, 25 volt, 100 volt? There's a lot of different specifications that go around that. So if you're doing business in O'Fallon, you should be very familiar with NFPA 72, because that's what the building inspector is going to look for when he comes out there. Do you have the right wire? Did you use conduit if you had to? There's a lot of things that go into that. NFPA.org is that website if anyone's interested. You do have to join. It's free to join. You can't download, but you can look at. You can pay for it if you want to download it, but you can look at it for free. And again, it's really very technical and it's really long. But it is very important because you got to protect yourself, you got to protect your business, you got to protect your clients. And the smarter that you can appear going in, the more you know going in, making recommendations. You know, a lot of business owners want to cut corners. Just put a speaker there, it doesn't matter. But if you're putting a speaker there that's not going to meet this, and you can save them from doing that up front, you look a lot more valuable to them, and your services become a lot more valuable, which is just going to help you get repeat jobs down the road from word of mouth and other things. Okay, so really important to know the code compliance for your area. So here's the state requirements for the state of Missouri to be an electrical contractor, which as a low voltage installer, that's what you are. And there are no statewide licenses required. You don't have to do anything to become an integrator. So congratulations, you're all 70 volt integrators. Welcome to the state of Missouri, all right? I like it. This is good to see because it's good and bad. Bad part is there's going to be some of your competitors out there that are also not licensed but may not have any knowledge. They're going to try and undercut bid jobs because they think they can get by with using a cheap 8 ohm speaker in an application that, again, depending on code compliance, may not qualify. So that guy's going to have a problem down the road. He probably won't be in business that long, which is good for you. But essentially the state of Missouri will let anyone be a 70 volt installer. So I downloaded North Carolina because it's the one that I found that was the hardest. North Carolina's got some regulation. So and this is just to illustrate the difference between states. So a statewide license is required for fire alarm, burglar alarm, and low voltage wiring systems defined as wiring systems of 75 volts or less and control circuits directly associated therewith, wiring systems that have a voltage in excess of 50 volts, which is what we're talking about, and consist solely of power limited circuits meeting the definition of a class 2 or class 3 wiring system in the National Electrical Code, which is exactly what we're talking about. Blah, 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 goes on and on. By the way, you got to pay $90 to take a test. You got to pay $85 to get a license, and then you got to pay $85 every year to renew that license. So being in Missouri is easy. Being in North Carolina, not so easy, right? But if you move, make sure when you move, you're checking out what's required. Because if you go in and start bidding on jobs and you don't have a license, especially in a union state, you might get your legs broken, worst case. But more likely you're going to be, you're not going to get the job because you're not certified to do it. So making sure that you understand what your responsibilities are in the area that you're living is really important. Questions so far?
I want to ask you one question.
Yes, sir.
Is it common that they use the sound system for emergency, like overhead? I mean, I can see it at an airport, but do they open strictly?
Well, so yes and no, it depends. So most buildings are going to have a fire alarm panel in them anyway. And in a smaller retail store and a smaller building, a little red box on the wall, which by the way we also sell, can be your fire alarm. That's really all that you need. If you're talking about a restaurant that's got a patio and maybe a private dining room and a front and a bar that's a little bigger, yeah, you could tie that into the fire alarm panel and use those overhead speakers as your alarm. That is possible. Additionally, if you're using a mixer mic that's got a microphone connected to it, maybe at a hostess station or in a manager's office or something, and there's a problem, that allows you to, hey everybody, you need to evacuate the building right now, sorry for the trouble, and get outside as fast as you can. Because if we were all in a restaurant, say it's Sunday and we're at Buffalo Wild Wings, we're 3 or 4 pitchers in, watching the Rams or whoever, and a fire started in the kitchen, would we know where to go? Would we know where to get out? It'd be kind of panic as everyone's running, where's the exit, this kind of thing. So having the ability to offer a customer, listen, we can put a paging station in case there's an emergency, and you can say, we have a fire here, calmly walk out this door instead of just setting off an alarm. Because I don't know about you guys, I ignore alarms. I travel a fair amount, and I've been in some hotels where the alarm has gone off in the middle of the night. I don't get out of bed. I don't go outside. I'm not gonna lie. I mean, I've been at airports where the scariest alarm I've ever heard has been going off. I'm just gonna sit here. I'm sure it's an accident. I'm not worried about it. I mean, we're conditioned that way. We probably all walk by car alarms going off all the time. There's not someone stealing it, but it's going off. So alarms don't really serve a purpose anymore. That's why with the IED guys that we're talking about, they do pre-recorded messaging. So if there's a fire, when you go to the airport and you hear that nice lady that says the white zone is for loading and unloading of passengers only, she records like 10,000 messages a year for us, and one of them is a fire message. So attention please, there is a fire, go to the nearest emergency exit. And in an airport there'd be wayfinding, you got to run this way, not that way, don't run toward the fire. But in a smaller business, if someone's just going to get on the mic and say, hey guys, we got a problem, go out the front door, go out the back door, it's just something else that you can add in. We're a very litigious country, right? We all want to get rich quick on the back of someone else. If we got to sue to get there, we're going to do it. So if you can, when you're talking to a customer and they don't have a need for paging, emergency paging is a need for paging, and everyone has that. Imagine that you've got a restaurant and somebody has a heart attack. We're back at Buffalo Wild Wings and we're having a wing eating challenge, and I start, seizing up. Rather than yelling, "Is there a doctor in the building?" It'd be much easier to get on a mic and say, "Attention customers, we have a customer that is in need of some medical attention. Is anyone available to help?" And then that person can come up and say, "Yeah," without panicking everyone, until the emergency responders or whatever get there. So adding in a mic to a 70-volt job, really in whatever kind of instance it is a big benefit. And we'll talk about that a little bit as we go forward. Any other questions? Yes?
Are you limited on your distance with your runs before you do anything at all?
You are going to be limited on your distance. I'll talk about that with this algebra in a second. If you're going to be doing really long runs, like say that you're going to do speakers in a building this size, you would be better off breaking them out and using like volume controls in those areas. So you've got a run going from volume control, and then you've got runs going out to the speakers still on all that same circuit. It would be better to do it that way than it would be to run a 2,000 feet of speaker wire, because you would get some loss at the end. Yeah. All right. So just to be completely honest with you guys, I studied political science in school because I hate algebra. And that was the only way that I could get out of going to more algebra. So this is not something I want you to memorize, but I want you to understand. Okay? What's that, Jeff? You sure? Jeff also failed algebra, folks. Jeff's the local rep here if you didn't know. You can identify him with the spiky hair. Okay, electrical power required. So if you want to do this the hard way, and I promise I'll show you an easier way to do this, but if you want to do it the hard way, okay, say that you're doing a job and you've got to figure out how much power you need at each speaker. This is the math equation that'll get you there. So EPR is electrical power required. SPL is the desired level at the listener. If we're at a bar and all the tables are standing, maybe it's a 12-foot ceiling, so maybe 8 feet, 6 feet probably, 5.5 for Bob, would be the listening height. If you're in a restaurant and most of the people are seated and that's where you want them to hear, maybe it's 4 feet. You just got to figure out where the listener is going to be depending on what kind of a building it is. A retail store, people are going to be standing. It's 5 or 6 feet. That's where they're going to hear. So it's the SPL, the desired level of that listener. Okay, so depending on the kind of store it is, if it's, Baby Gap, maybe the level is sort of quiet and it's just background music. But if it's Hollister, maybe it's got to be loud enough that I can't even talk to somebody standing next to me. It just depends on the kind of store. When you're talking to your customer, this is where it's important, because the customer's expectation is your reality. Okay, it's very important to remember. The customer's expectation is your reality. So if in the customer's mind, it's going to be crazy loud all the time, but you never ask them how loud they want it, and you turn it on the first time and they say, "This is it?" Well, guess what? You're getting back on that ladder, you're swapping out speakers, you're changing transformer taps, you're doing a lot more work than you want to. So defining expectations, very important in the commercial world, because nobody wants to get back on the ladder once you've done it once, all right? So PF. PF is the peak factor. If this place gets super busy, how loud does it have to be in order to overcome some of that ambient noise level of conversation or people yelling or whatever kind of business again it is? There's a difference between 11 a.m. at a Chili's and 10 p.m. at a Chili's on a Friday. There's definitely a volume difference in just the amount of people that are in there talking. Transformer loss. There is going to be some loss through the transformer. It's not going to be a lot. Probably 1/2 of a decibel to 1 decibel depending on the transformer. But you got to account for that, because as the signal is coming in, the transformer is going to lose some of that signal. The line loss, how far it is to the actual speaker, and then what the impedance of the amplifier is at that point in time. Then this 20 log equation, which it took me a while to figure out how to do on my Apple phone calculator. But I eventually got it worked out, and I can show you that later if you're interested. D2, the distance from the loudspeaker to the listener. R is the reference distance for the loudspeaker sensitivity. Important there is that when you're looking at a specification for a speaker, if it says sensitivity is 87 dB at 1 watt 1 meter, 1 meter is your answer. If you're using 1 meter, make sure that your number above that is also in metric. So do not use 8 feet divided by 1 meter because it will be wrong. Use 2.3 meters or whatever 8 feet is, or you can use 3.82 feet and 8 feet. You just got to make sure that you're using the same conversion on both. And then minus the loudspeaker sensitivity rating. So if it's 87 dB at 1 meter, and then divided by 10 and 10 to the power of, it's really a complicated equation. And when you break it out, let's say that this is you want it to be 75 dB at the listener with a max ever of 85 dB. We know that we're going to lose 1 watt through the transformer. We're going to lose a half a watt through the line. If you look at my chart down here, this talks about impedance loss over distance depending on wire gauge. So you can see it's not losing a lot, but if you're talking about 1,000 feet of wire or 500 feet of wire, you're going to get some loss in there depending on how much you've got in the system and how far you're going. Times 20 log, I'm using 8 feet as my reference distance to the listener, 3.28, which is my 1 meter, and then 87, which is the speaker sensitivity. Math works out, I need 5.3 watts per speaker. So if you're going to do this, would you get a 5 watt speaker? No, don't get a 5 watt speaker. It's not going to be loud enough. Your best bet when you're doing this is if you wind up with a number like this, 5.3, generally a speaker tap's going to be 1, 2, 4, 8, 16, 32, or 1.5, 3, 5, 7.5. There's some variables in there. But you always want to choose a speaker that's got a transformer at least 1 tap setting higher than what you need. And you're always going to probably be better off tapping it at that. And then installing volume controls. Okay, because the customer, this might be a new restaurant that you're working on and the customer expects it's going to be a family-friendly place, and then 3 months from now, it's where all the 20-somethings are hanging out getting drunk, and it's not loud enough. So now they're like, oh, it's not loud enough. They're calling you. You're back out there anyway. If you do your work up front, put in a louder speaker, tap it at a higher level, put in a volume control. That way you don't have to come back. You can just tell them to turn it up. Pretty simple, pretty easy, and it gives the customer the flexibility to adjust that control during the day or during the night, whatever it is that they're doing. Especially if you can mount that somewhere that's in an employee area only, but not necessarily locked up. A lot of times the rack is going to be in a back room, probably with a door on it, maybe locked. So, if that's the manager's office and the manager only works till 5, you don't want the night guy going in there and blowing up all your knobs, because depending on how it's set up, you don't want to blow up the system, because then you got to come back out there and replace speakers or amplifiers or that kind of thing. So volume control could save you a lot of headaches down the road. All right, so recommendations. This is just very general recommendations. Okay, I'm probably talking right now at 75 dB. That's what this conversation is that we're having. That's the general noise level of conversation in a room that doesn't have any background noise, where I can just talk to you guys. So when you think about something that's 55 or 60 dB, much less than what I'm talking at now, but that's why it's called background music. If I'm shopping at the Baby Gap, pushing my kid in a stroller and he's sleeping, I don't want, rock music blaring me out at 85 or 90 dB. 55 is plenty, because I just want to be able to hear it. It adds ambiance, and it's something that most people can handle without getting, overrun by it. Medium noise, restaurant, shipping department, depending on what kind of install you're doing. I think this one's probably a little low, 65, depending on the restaurant. Again, if it's just background music and you've got 30 tables, there's going to be a fair amount of talking there. But adding that volume control and giving the customer the ability to turn it up will be a big advantage for them and for you. High noise areas, supermarkets, factories. You guys could conceivably, I would say a supermarket's actually pretty easy. It might sound difficult. I've got an example in here of a supermarket install that's not too difficult to do. A warehouse. A warehouse like this would be pretty easy. Some horns around and an amplifier somewhere with a paging mic, so you could, it's time for lunch, you could attach a bell to it, whatever it is. But again, you've got machines driving around, forklifts, that kind of stuff, so there's some other noise that's going to be there besides conversation. And then max noise. If anyone does a printing press, I'd love to be there, because I think that'd be awesome, because those machines are super loud. And at that point, it's really more for paging and safety than it is for background music. We deal with a couple of printers. I've never been in one where they were playing background music. It's always for, there's a truck and receiving, someone's got to go help, or it's time for lunch, or it's break time, or whatever. But those are just sort of general guidelines. you can see that we recommend regular speakers for some of that lower end stuff, and then PA speakers, like a horn for the louder places. Because at that point, you're just trying to get paging out. You're not really doing music. PA horn is not good for music. You know, it's crossed over at probably 250 hertz, so it plays nothing low. So if you try and play music through it, chances are you're going to blow it up, which we'll talk about in a little while. But that's why you see that difference between those two columns. And then recommended power taps. I know you guys see that half watt and you're like, that's ridiculous. But we'll talk about in a minute how you don't need a 150 watt speaker to get a good amount of sound in a 70 volt system. Okay, does everyone know what this is? This has become my best friend. I actually put it on the home screen of my phone because, again, failed math. I have a bad memory because I drink a fair amount. And so the Ohms Law Wheel is going to be real helpful in when you're on the job, or when you're doing a job, or when you're designing a job, and helping you to figure out what you're trying to do. So my first example here, if we had 10 speakers at 150 watts, we're trying to figure out what our ohms value is of this system. So 70 times 70 divided by 150, we know that our ohm value is 33.66. So the reason I'm showing you this is that if you have an impedance meter, not a multimeter, a multimeter only measures DC resistance. An impedance meter actually will send out a 1 kilohertz tone into your speaker line and then return back what that impedance load is. So the important thing here is that if you know that you've got 10 speakers at a total of 150 watts, your impedance meter should come back to, you know, within 5 or 10% of that 33.66. If it comes back with something totally different, something has gone wrong. And either speakers are mistapped, so there's a short in the system, somebody tapped something at 8 ohms on accident, which happens all the time, but you know that something is a problem. The reason that this is important is because if you have a mismatched impedance on your 70 volt amplifier, it is going to be unhappy. Eventually it is going to break. You're going to come out when your customer calls you because something is not right. You then have to troubleshoot the whole thing. You find out it's the amp, you take it out, you send it back to Skywalker, Skywalker gives you a new one, you put it in. A week later, you're back for the same thing. Now you think your Atlas amp is junk and you want something else, so you go get something else, you put it in, a week later it fails. Now you're back in Atlas's good graces because it's not my fault, and now you've got to troubleshoot that speaker line. Okay, again, that is a lot of wasted trips, a lot of wasted money, and a lot of wasted time. Okay.
Do they put that number on the print that the Atlas factory makes, the engineers that make it? You said you were going to have them design a system. Will they put all those numbers on?
They can, sure, yeah. I mean, you can ask them to do that, what your final impedance should be. Does everybody own an impedance meter? It's not a relatively available tool. I don't even think Skywalker carries them, Randy, to be honest with you. I looked online. But it may be something that you think about. I don't even know where to get them, to be honest with you. I always borrow the one from one of our guys in the office if I need it, when we take it to shows and stuff like that. But it's it kind of looks like a Geiger counter almost. You know, it's got a little arm and it measures the impedance with a little click of a button. But it's a handy tool to have in your bag when you're doing these systems, because you don't want to do it wrong and wind up coming back. Just a reverse of this, if I'm trying to find out, do I have a 70 volt system? You know, maybe you're going out to troubleshoot someone's job that did it before you. You know, maybe someone else installed something. Customer has no idea what it is. You can't really tell. You know, maybe the system's failing and they've lost confidence in that guy because he just kept replacing the amplifier, right? Never checking the line. And you want to go out there and see, well, what exactly are we doing? You could do your math this way. If you know it's supposed to be 10 speakers at 15 watts, you can figure out is it a 70 volt system? You know, is this working out the way that it's supposed to? If not, then you know there's a problem either in the speakers or in the amplifier. You know, maybe they hooked it up wrong and you didn't see that at first when you went to troubleshoot it. But this math will work in a variety of ways to help you figure out and ensure that you're doing the right thing for what you're doing. Okay, how many speakers do you need? This is always an interesting one. You know, your speaker placement should be twice the distance of your height from the floor to the ceiling. This is essentially what this slide is telling us. So if you have an 8-foot ceiling, your speakers should be 16 feet apart. If you've got a 10-foot ceiling, they should be 20 feet apart. If you've got a 12-foot ceiling, they should be 24 feet apart. There's that math again. I'm telling you, I'm terrible at it. If you square that number, the distance, you'll get the total area covered, or that you need to cover. That's a better way to put that. Okay, so if you have an 8-foot ceiling, they're 16 feet apart. 16 times 16 is 256 feet. You got to have a speaker that's going to be able to cover that amount of space. Okay, so when you talk about speakers, one of the things that a speaker specification lists is dispersion. Okay, dispersion is not something we ever deal with in home audio. You know, speakers in front of you, plays sound, you hear it, life is good. It's above you, it plays sound, it comes down on you. We're not really worried about in a smaller, 15 by 15 living room what that dispersion needs to be. But in the 70-volt world, dispersion can be anywhere from 30 degrees with a horn, up to 130 degrees, depending on the type of speaker that it is. Wider is not necessarily better. You'll hear that a wider dispersion will give you greater speaker coverage, allowing you to have less speakers. While that technically is a correct statement, the volume that you're going to drop off may be too much for the listener at the listening level. So adding more speakers with a narrower dispersion may be better depending on the type of job that you're doing.
How about outside? Because I have applications for that once in a while.
Outside, absolutely. So you'll look at a speaker like the speaker that I've got mounted on this rack right here, this little guy. So that's a 4-inch all-weather speaker. I think that's 90 by 90 on that. So depending on where it's going to give you pretty good coverage. If you're going to mount them straight up, you're going to get a nice coverage down. If you're going to mount them on a wall, aim it at a seating area, you're going to get nice coverage there. I've got a football field slide here that I'll show you. We offer a couple of different 65 by 65, 90 by 40, and 90 by 90 options depending on what you're trying to cover and how much ground you're trying to cover. Remember, I think I have it in here. I think I have it in a second, but the inverse square law, every time you double the distance, you lose 6 dB. So that's another thing that's important. So if you've got the speaker mounted on the wall and it's 87 dB at 1 meter, at 2 meters, it's now 81 dB. So if you're trying to make sure that this guy hears 87 dB, you're going to have to crank the wattage on this guy in order to compensate for that distance. And then if you've got a guy that's 40 feet away, it's even more. So just all these kind of things to think about. So dead zones. Nobody likes a dead zone. Not in a speaker world anyway. So a dead zone is an area that is not getting coverage by the speaker. Nobody wants to sit in a restaurant and be in the space that there is no sound coverage. Now, is there not going to be any sound coverage in a restaurant? It's probably an unrealistic comment to make because most restaurants are tile floors, hard tables, glass windows. There's a lot of reflective surfaces. So are you going to be able to hear the music still in a dead zone? Yes. Is it going to sound good? No. Is it going to be, sort of an amalgamation of all these reflections coming together? Probably. So is that guy getting the best listening? Probably not. So when you do a speaker design, you want to make sure that you have no dead zones. So you've got to take into consideration your ceiling height and your dispersion in order to make sure that you're going to cover the entire area so that there are no dead zones. I've been into restaurants where there's 4 speakers in the ceiling and the dining room's like, 30 by 40. It's unrealistic to think 4 speakers are going to cover that. A lot of business owners think that audio is the least important thing that they're adding. I don't really need that, blah, 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 blah. But I think that we could all attest that shopping or eating someplace that's got some life in it as opposed to being super quiet and nothing exciting going on, you're more likely to go back to that place than you would be to eat somewhere that's not as exciting or boring or whatever. So making sure you got the right speaker coverage. This is even crazier right here. So we want no dead zones at all. We're going to cover this entire floor with sound. This is probably the optimum way. It takes more speakers. It's going to be more expensive. But by illustrating something like this to the business owner where there aren't going to be any dead zones, it's always going to sound good. It's easier to sell down than it is to sell up, right? So if you're going to design build or you're, if you're bidding on something that's already done, the architect already did it or the acoustical engineer. But if you're doing design build work, showing them this before you show them a 6-speaker version of it, it's going to be a lot easier to say, okay, well, let's take some speakers out. We still have enough coverage. We can still move forward this way than it is to say, okay, I can do it with these 6 speakers, you're going to have these dead zones at this price, or you can do it with these 12 speakers and you're going to have no dead zones at this price. Well, they're going to be like, oh, this is probably good enough. You know, we've all been selling for long enough that it's way easier to sell down than it is to sell up. So making sure that you've got them coverage pattern in all areas is going to be important. Okay, SPL Calculator. Again, Atlas Sound support page. We'll do the math for you here. So you just type in what your sensitivity is right in that box, and then you put in the distance you're going to be at and hit calculate, and it will tell you that you're going to lose 6 dB per doubling of distance. So this is something that you got to account for. So at 20 feet, we're kind of in between there, probably 75. So, nope, sorry, between that one. So we're going to be somewhere in the neighborhood of 73 dB, 20 feet away. So we've lost 12 dB from what our speaker was putting out. So we've got to account for that in our electrical power required algebra equation. Question on that? Okay, so if you're lazy, like I am, and you don't want to do all that math or even do all that thinking, again, visit the Atlas Sound webpage and click on Strategy 2 Series Speaker Selection and Placement Tool. And then we'll do it for you. So all that stuff that we just talked about, you don't really need to worry about because I have a sheet that'll do the work. So if you go in here and how wide's my room, how long is my room, how high is my ceiling, so listeners seated or standing, these are all drop-down menus, so you can just choose the option that you want. This will give you a drop-down menu of 12 to 14 different Atlas speakers. You want to know about the speaker first because you want to make sure that it is the speaker that you're looking for. It's got high enough taps and that kind of thing that it'll work for you. And then you've got to tell what you want to tap the transformer at. It will then tell you how many speaker rows you need, how many speaker columns you need, how many total speakers you need, how much distance should be between each speaker, and where you should place the first speaker. So if your room is a 60 by 40, that's 10 feet off choose a corner, it's 10 feet, 10.4 feet up, 10.4 feet in, mount your speaker, then measure 20.8175 feet, mount another speaker, 20.8175 feet, mount another speaker, and then go the other direction, your system's set up. So while I want you to know the math and understand the math, if you don't want to do it, we'll do it for you, okay? This is way easier, by the way. That EPR thing is nonsense. Whoever invented that, I hope he's suffering somewhere. Okay, wire gauge. This was a question that we had earlier. What do you guys use now in a home when you're doing an 8-ohm system? 12 to each speaker? 14 to each speaker?
16 and 14.
16 and 14 still? Okay, good. All right, you can use the same thing. 16, you can actually use 18, depending on the distance you're going. If you're going less than 50 feet, 18 gauge is going to be fine. If you're going more than 50 feet, more than 50 watts, I would use 16. But just standard 16.2, Skywalker carries a whole variety of it. Free shipping, all that kind of good stuff. Pretty easy. Now the other things to consider, as we talked about earlier, what is required by my AHJ, my authority having jurisdiction? If you're going to run some speaker wire outside, does the local code require that it is all-weather wire? Because if you put wire outside and you leave a little bit, copper corrodes, especially in a humid environment like St. Louis. You don't want it to come back out there and replace speaker wire. That would be nonsensical. So you got to get wire that's weatherproof. Does it need to be UL rated? That is a thing. Does it meet UL certification or NFPA certification? Is it class 2 or class 3 wiring? What are you connecting that you need to make sure it's going to meet that code compliance? So things to consider, but 18 or 16 generally will be all that you need. Okay, so 70 volt versus 8 ohm. It's easier to wire. You don't need to worry about series parallel. There's no run the plus of this to the amp and then the negative to the plus, negative to the plus, negative to the plus, blah, 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 blah. So I can get, a 2 ohm load or whatever I'm trying to aim for. You don't need to buy a 10 or a 12 or a 16 channel amplifier and run a home run to each one. So it's much easier to wire. Speaker wire starts at the amp, goes to the first speaker, goes to the second speaker, goes to the third speaker. However many speakers you have, it's one speaker wire, that's all you need.
They're probably all wired the same though, right? Is there a
It's plus and minus. So like if you, when I pass this thing around, there's a wiring sheet on the back of this one. A couple of different wires, depends on the tap you want. But yeah, so it's your common and then it's whatever your power that you want. We make some of these speakers have Phoenix connectors on them, labeled plus and minus. As long as they're all plus and minus, no problems. Okay, a lower gauge wire, less of it. You don't need to use a 12 or a 14. You can use a 16 or an 18. It's less expensive electronics. If you're doing, a lot of our home amps are complex. They've got DTS or Atmos, and if I'm a restaurant or an office, I don't need that. I'm gonna plug my iPod in. You know what I mean? I'm gonna put DirecTV into this thing. I don't care about surround sound or this other stuff. So the electronics are much more basic, much less expensive to your customer. Okay, reduced install time. One run goes the whole way. Instead of a run out and a run back and a run out and a run back. Sound quality, this is one of the big knocks about 70 volt is you don't get the same sound quality that you do with an 8 ohm system. There's a little bit of truth to this. Don't use 70 volt for home theater. Okay, I'm just going to go ahead and say it. Don't put a 70 volt system in for home theater because your customer will be disappointed. But if they just want music and it doesn't matter about stereo separation, it's going to be in a hallway, it's going to be in an office, it's going to be in the kitchen. It's going to be in a waiting room. It's going to be in a restaurant. 70 volts is going to give you more than enough sound quality. Where you lose sound quality in a 70 volt system is in the transformer. Okay, the transformer stepping down the voltage from the line into the speakers where you lose sound quality. And for a long time, transformers were very poorly made, and you lost most of that on the low end. So nothing 150 and below. Transformers are much better now. The sound quality is much better. We make tuned and ported enclosures now that actually sound musical when you put them into a restaurant or another place. We make subwoofers that can go into the ceiling, that can hang from the ceiling. So we actually have a product that has a 70 volt transformer in it that will play low frequencies in order to be able to give that. Yeah, everyone knows Mrs. Bass. We were at Sturgis this year on our car audio side, and every single motorcycle. Can I put a sub in this? No, you can't put a sub in a motorcycle. You're being ridiculous. But we can't put it in your building. Okay. Because everyone wants more bass, no matter what kind of music they listen to. And then highly reliable. Properly set, a 70 volt system should run forever. Literally run forever. As long as it's set up properly and it's tuned properly, and once you tune it, you rip the knobs off so that the owner can't get in there and mess around with it, it will run forever. No one's going to jack it up and blow speakers. No one's going to jack it up and blow amplifiers. You should be able to set it and forget it. And I've got a couple products here that I'll show you guys in a while that reinforce that and just make it easier for you guys to do your jobs. But much more reliable than an 8 ohm system. So those are sort of the pros and cons between the two. Let's answer some questions, and we're going to take a short break. 70 volt, come on. I'm all the way here from Arizona. You guys got to ask one or two questions.
What about, because the big advantage for me with an 8 ohm system is again multiple zones and multiple sources. So what can you do with the 70 volt that would be comparable?
Well, so if you had a mixer amp, you could do multiple sources. And then you could do volume controls in zones. A lot of our amps do have zone 2 outs, so you could run 2 amplifiers if you wanted to. And at that point, you could run a power amp, so you just have one source going into one source going into the other, or you could transfer that through. There are ways to do it with a 70 volt system. A lot of bars will do that. Maybe they want to show the Rams game inside, but they're going to show the Blues game outside, so they want to be able to distribute the sound to do different areas. It's all possible. It's all possible. The one thing that 70 volt doesn't do that AV receivers currently do is HDMI switching. So if you got a lot of HDMI boxes, you got to buy an actual HDMI switcher that's got an analog out to go to an amplifier, as opposed to a Onkyo. It's got 4 or 5 HDMI inputs into it. That's really the downside to that. But the applications don't normally lend themselves to that as much as they do in a home, where they've got you've got DVD or Apple TV plus your cable box and all these other things that are all HDMI now. But yeah, multiple zones is 100% possible.
Along that same line, if you got a restaurant and they got a holding area for people that are waiting for a table.
Sure.
When they page and say a table's ready for so-and-so, they don't need to have that in a restaurant. They can break that out.
You can do that, yeah, sure. What you would probably do in that instance is you would have a mixer amp that's got the mic going into it, and then you would go out to another smaller amp that would be a to that waiting room. And when I say a smaller amp, this is a 20 watt, 70 volt amplifier, which we'll talk about in a little while. Take a 10 watt version of this that's half the size. You can mount that anywhere, run it to 2 speakers and call it a day. Be more than you would ever need.
So at that point, is that just going to run like to local? So like he was talking about for at the hostess station, or whatever, that's going to be at the hostess station?
Could be, yeah. And then the speaker wire from that goes out to the waiting room or the lobby, wherever the people are. Maybe it's a horn that's outside. Your table's ready because it's overflowing outside. Got a couple of different options for how you could use that.